Ever wondered what is statistical learning in machine learning? Well, let's dive into this fascinating topic. Statistical learning is a type of machine learning that involves creating statistical models for predicting outcomes. It's the backbone of many algorithms that power the AI systems we interact with every day. From voice recognition software to recommendation engines, statistical learning plays a crucial role. So, why is it important? It's because these models help us make sense of complex data, enhancing the machine's ability to learn. Keep watching to unravel the mystery behind statistical learning. Statistical learning, in essence, is using statistics to learn from data. It's like being a data detective, using algorithms as your magnifying glass to delve into the complexity of data and uncover hidden patterns. Let's break it down. You can think of an algorithm as a step-by-step procedure for solving a problem. In statistical learning, these algorithms are used to build models, or simplified representations of reality, that help us understand and predict data patterns. The algorithms essentially learn from the data, much like a child learns to recognize shapes or colors. Now, when we talk about learning from data, we're referring to two main types of data: training data and testing data. Training data is like the textbook for our algorithms. It's the data we use to teach our model about the patterns it should be learning. We show the model the input and the correct output, and it learns the relationship between the two. Once the model has been trained, we introduce it to the testing data. This is like an exam for our model. We want to see if it can correctly predict the output based on the input, using what it learned from the training data. But what's the point of all this learning? Well, it all boils down to prediction accuracy and model interpretability. Prediction accuracy is about how well our model can predict the future based on what it has learned from the past. It's like forecasting the weather or predicting the stock market. The more accurate our predictions, the more valuable our model is. Model interpretability, on the other hand, is about understanding why our model makes the predictions it does. It's about being able to explain the reasoning behind the model's decisions. This is crucial in many fields, such as healthcare or finance, where understanding the why can be just as important as the prediction itself. So, statistical learning is about making sense of data and predicting outcomes. It's a blend of statistics, computer science, and a bit of detective work. And it's a key component to the exciting and ever-evolving field of machine learning. Now let's delve deeper into the key aspects of statistical learning. To start with, statistical learning generally falls into two categories: supervised and unsupervised learning. In supervised learning, we have a target variable, or in simpler terms, an output that we want to predict or classify. The model is trained on a labeled data set, meaning that we feed the model both the input and the desired output. This allows the model to learn a function that maps the input to the output. It's like teaching a child to recognize shapes by showing them pictures of different shapes and telling them what each one is. On the other hand, unsupervised learning is like an unguided exploration. Here, we don't have a target variable. Instead, the model learns by uncovering hidden patterns in the data set. It's like giving a child a jigsaw puzzle and letting them figure out how the pieces fit together without any guidance. Now, let's briefly touch upon some common algorithms used in statistical learning. Linear regression, for example, is a supervised learning algorithm that models the relationship between two variables by fitting a linear equation to observed data. Decision trees, on the other hand, are used for classification and regression tasks, creating a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. And then we have k-nearest neighbors, an algorithm that classifies objects based on the closest training examples in the feature space. Understanding these aspects will give you a solid foundation in statistical learning. It's time to tie up all the loose ends. So what have we covered today? We've journeyed into the realm of statistical learning, shedding light on its definition, a set of tools for understanding data. We've emphasized its pivotal role in machine learning, where it helps us to model and interpret complex data sets. We've also unlocked the concept of training and testing data, understanding how they're used to build models and evaluate their performance. Remember, a balance between prediction accuracy and model interpretability is key. We don't want to overfit or underfit our models. Moreover, we've explored the various types of statistical learning, from supervised to unsupervised, each with its unique approach and application. And finally, let's not forget the importance of choosing the right method for the task at hand. It's not always about the most complex solution. Sometimes, simplicity is the ultimate sophistication. With this knowledge, you are now well equipped to further explore the fascinating world of statistical learning and machine learning. Until next time, keep learning.